Hello, good morning all. I am Dr. Abdul Pasha, Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad, from the Department of Electrical and Electronics Engineering. So here it is about the course Power System Operation and Control. So in this course, here it is about the discussion Flexible AC Transmission Systems. So this flexible AC transmission systems will make the entire whole power system network to be operate as a predefined quantities. That means we are going to utilize some parameters in this case, so which are to be mostly suitable to undergo the working operation of the power system networks. So these are going to discussed with one of the fax controller devices to nullify or rectify the problems associated with the power system components. So usually we suffer with the harmonics, voltage imbalances, current imbalances, power factor issues. So all these are the major components which will mostly influence the power system network. So here it is about flexible AC transmission systems. So here electric power supply systems of entire universe are supposed to be interconnected in involving the connections inside the utility case. That means that may also treated in their own territories with external to inter-utility case, international standards to their inter-regional and then international connections case. So what happens with this means when the systems are involving in more connection contacts, then there may be network issues while connecting to their within the whole of the networks. It may be external or internal cases. These are the time changely aspects which may vary time to time. So this is usually done for economic reasons. So economic reasons means cost of the equipment may impacts on the whole power system network. So this is to reduce the cost of electricity and to improve the reliability of the whole power system network. So because of that, we need that interconnections are ready to accumulate the power plants and also the load centers. This is in order to minimize the total power generation capacity and also the fuel cost. This is much more influence the whole system. So usually the transmission lines are going to be interconnected. They are enabled to supply, to give the supply case electricity to the loads where they connected far away distance. These are supposed to be done at minimized cost. So this will require with reliability conditions. So fax technology is usually adopted in the transmission networks to enhance the grid capacity, also reliability case, and also to overcome the practical difficulties which may occur usually in mechanical devices, and they are used as one of the controllers. That what I suggested, fax controllers for the transmission of the whole network. So actually when we discussed about transmission network, so these networks are connected over long distances. Why? Because as we know that where the generation system is there, where the load is connected. That means all the loads are not connected nearer to the load centers. So that must be a huge gap in between generation and distributed loads. So this may be done usually with the whole transmission network. But what's happening here is that means carrying the power over long distances. When you suppose to carry the power over long distances means there is an expectancy of the loss quotient. So this may be in any of the form, loss quotient, as it may be heat loss, I square R loss, or any imbalance of the parameter that may also loss. This impact is usually on the load case. So this is to minimize the system efficiency. So as to minimize all these loss coefficients, we must connect with some fax controllers that we are discussing now. So this has to be done usually. So coming to this, when you are carrying the power over long distances, that means the length of the line is increasing. Usually, if you see any transmission network that should be traveling over hundreds of kilometers, wherever the generation which should be located, it may be hydel or thermal or some other sources of energy that should be situated at somewhere far away distance. So we are getting the power from that, means it is carrying over long distances, hundreds of kilometers, sometimes thousands of kilometers. So this may be difficulty at the load case. Why? Because we cannot see the exact form of the power, what it is delivered or generated at the generating station, maybe hydel or thermal or some other sources of energy. So we cannot expect the amount whichever we generated. That's why some manipulations will be done, means there should be some corrections whichever the power is supposed to be generated at the generating station. So that corrections may leads to the whatever we require. That means we can reach to the targeted value. So these are the some simple manipulations will be done in meanwhile as the power is going to be transferred from one end to another end. So this should be also one of the impact for the whole power system network. So as the line is interconnected more with all the components, so we have to look into each and every system. Why? Because we cannot expect that at only particular location we can see the loss quotient or result like that. So here the fax technology has opened its new opportunity to the transmission network for controlling the power and enhancing the usability capacity. So that should be happening nowadays, and also to upgrade the transmission networks, whole transmission network upgradation. We are also using this type of one of the fax controller networks. So coming to this, when the current through the line can be controlled, what's happening means at a reasonable cost, whichever it will be enables large potentials of increasing the capacity of existing lines with large conductors, and with the utilization of fax controllers, power flow through the lines also maintained stable. So we should look into that, whatever the power flowing through the lines, that should be maintained stable case. Why? Because just I told you, we need to reach to the load target. That means as the loads are designed according to the various ratings, it may be motors or industrial or domestic or commercial loads, they have certain ratings and specifications. We need to reach to their specifications and ratings. If not, this may be impact on the load performance, as the loads may got damaged or malfunctions, or it may got shorted. So all these are the issues we may see into the systems. So fax controllers are ready to control the parameters that should be governing into the operation of the whole transmission network. So such kind of series impedance, shunt impedance, current, voltage, phase angle, damping oscillations at various frequencies below the rated levels. So all these are the considerations which should be designated for operating one of the suitable fax controller devices. So we should select as the impedance in series or parallel, or voltage current devices, maintaining the phase angles, that means suitable rating of the power factors, providing suitable dampings. If not, then it should suffers with the harmonic contents. So all these are the issues we may suppose to face during this connecting the circuits of the whole power system network. So usually in AC power system network, so generation and load must be balanced at all the times. That's what I am saying now. So if not, balancing means we cannot reach the specifications of the load requirements. So since all the electrical systems are supposed to be in self-regulating manner, so therefore one of the generators they are ready to supply the less power than the load means voltage and frequency drop, load goes to the high and it may be decreasing to equalize the generated power by subtracting the transmission losses. This may usually happens by removing from one of the coefficient. So usually there is a small margin for self-regulating case. If the voltage is dropped due to the reactive power coefficient, so load will go up and frequency goes to high on decreasing and the system will collapse automatically. So this may usually happens. So we need to take the measures as we need to substitute for reactive power compensation devices that will fulfill the voltage requirement of the system. So if not, that impact is more on the load. We cannot balance the system. So meanwhile, in the line case, we need to substitute these compensation devices. Compensation devices are ready to substitute in the mean of the line. So here also the system will also drops if there is a large reactive power available in it. So in case of high power generation, what happens means active power flows from huge aspect, that means surplus in nature, generating area to the defected area case. So how power flow usually happens means by considering a simple case of power flow in parallel paths and coming to the power flows from huge generation area to the defected generation area. Power flow is based on the inverse of the line impedance case. This may usually happens in the power flow aspect. So it is likely that lower power impedance like it becoming overloaded and limits the loading on both the paths. That should be through the higher impedance area which is not fully loaded. So there should not be any chance to upgrade the current capacity of the overloaded path case. So because it would further decreases the impedance case. So power flow with the HVDC converters are controlled by high speed HVDC converters. These converters may make the operation to be superior over the working of the power system network. So here the parallel path of the AC transmission is ready to maintain the stability of the power flow condition. So as the power flow control with the fax controllers can be carried out by the means of controlling impedance, phase angle and by injected voltage in series. So for better understanding of the flow of power, it should be considered with the simplified case in which simple two generators are sending power to the load centers from which different sides may goes to be happens. So mesh network has the lines with considerations from A to B, B to C and A to C. Like that we will have some mesh networks which is having continuous rating about 1000 megawatts, 12,050 megawatts, like that. It may usually happens. So this is to be done frequently. So this is the network showing how the power flow in meshed paths. So this contains the meshed path network. For example, this will contains with the one of the loads with 1400 megawatts about 10 ohm and 600 megawatts at 10 ohm, 2000 megawatts, 1600 megawatts about 5 ohms, 1000 megawatts. So like that the load is connected into the 3000 megawatts load with connecting to the ABC formations. This is the AC mesh network. So this will indicate the power flow in meshed or looped networks. So how the power is flowing with the various conditions of the power networks. So here if one of the generator is generating a power about 2000 megawatts and other is about 1000 megawatts, then total power of the 3000 megawatts should be delivered to the load center. This happens usually in mesh networks. So whatever the diagram that I have shown here in this power flow, the three impedances, whatever we treated here, 10 ohms, 10 ohms, 5 ohms. So these three impedances which will carry the powers about 600 megawatts, 1600 megawatts and 1400 megawatts respectively. So such situation would overload the line BC here in the overloading the line BC, and therefore generation would have to be decreased at B point and it should be increased at A. This is in order to meet the load without overloading the line about BC. So coming to the second figure, what is happening here means we are connecting one of the compensation device about minus 5 ohms into the line which is carrying a power of 1750 megawatts at 10 ohms impedance case. And this is feeding with the 2000 megawatts. So here also three considerations: 600 megawatts about 10 ohm impedance, 1250 megawatts about 5 ohms impedance. So like that load is connecting at 3000 megawatts about this condition. So if the capacitor of reactance about minus 5 ohm at a synchronous frequency is inserted, means the line is AC is about to reduce the line impedance factor, that is from 10 ohms to 5 ohms, so that power flow through the lines AB, BC and AC are going to be maintained at 250 megawatts, 1250 megawatts and 1750 megawatts respectively. So here it is clear about that if the series capacitors are adjusted, that means power flow level may be realized suitably. So complications is that if the series capacitor is mechanically controlled, means may leads to subsynchronous resonance case. So this subsynchronous resonance case may happens with the complications of the series capacitor. So this should be manually controlled, means reaching to the one of the factor of subsynchronous resonance factor. So this resonance occurs when one of the mechanical resonance frequencies which is about to the shaft of multiple turbine generators, they supposed to coincides with the normal frequency by subtracting them to the electrical resonant frequency case of the capacitor with the inductive load impedance of the line case. So then the shaft will be damaged automatically. So this is to be done at the various frequency ranges. So this resonance is going to be occurs means when one of the mechanical resonance frequencies of the shaft for multiple turbine generator unit coincides with the normal frequency range. That means this is to be subtracting from the electrical resonance frequency of the capacitor. So this is done with the inductive load when impedances of the line is matched. And also the shaft will going to be destructed. So this we need to look into that to save the shaft from happening of the frictions which is impacting onto the line. So this will be the diagram representing power flow in meshed paths. So this is to be situated with the 10 ohm impedance 1750 megawatts. Again 10 ohms impedance with the 250 megawatts here. And here 2000 megawatts with 5 ohms impedance. Here 1000 megawatts with 7 ohms. So external impedances are connecting means as the compensation of the line is going to be done. So here 3000 megawatts load is going to be feeding at the point of C. So like when you are going to compensating the line at various factors, means the line is going to be energized more. So if the series capacitor is supposed to be thyristor controlled in nature, that means it's supposed to be varied when it is going to be required by the gate controller. So actually we know that thyristor contains 3 terminals, anode, cathode and gate terminal. So the gate control can make sure about controlling the parameters through this case. This is the G, this is anode, this is cathode. So the control action is through the gate terminal. The gate will ready to control. So if it can be modulated to rapidly damped and subsynchronous conditions. That means it can also be modulated at damped low frequency oscillation. That means transmission system goes to from one steady state condition. That should be happening to the another. This should be done without the risk of damaging the shaft and the system will automatically collapses. So here, in other words, we may say that the thyristor controlled series capacitor can enhance the stability of the network. That means impedance of the line when it is connected under BC point, this is increased by inserting the inductor of the reactance in series with the line AB. That means series inductor which is controlled by thyristor, that could serve to adjust the steady state power flow and dampen unwanted oscillations. So this is to be done usually to make sure about the line to be energized or not, any lagging cases of any one of the parameters in voltage, current and power. So power factor also to be look into that to maintain constant or not, under leading conditions or unity operating conditions is there or not. Those are the things also we need to check over this. So this must be ensured to operate the power system network to be suitable. So this is the diagram showing the power that should be meshed into the lines about minus 4.24 impedance of the line, about to flow through 1750 megawatts, about 10 ohm impedance. This is to be done at 2000 megawatts. So and 250 megawatts of the load is supposed to be connected across 10 ohms impedance. That means 5 ohms impedance are going to be making the path about 1250 megawatts. So this 1000 megawatts about 7 ohms and 3000 megawatts load about this line may make sure about the system parameters to be straightened to the whole network. That means this distribution of the power among the lines in meshed paths means, so then continuity of the supply may reach to the load end, and we can make sure that the line is going to be energized with all the compensated paths. So due to which we can avoid the lagging of the power coefficients into the whole network. So here one more option of the thyristor controlled methods are, that means phase angle regulators could be installed in the series capacitors in the lines, that should be shown. So regulation is installed in the line means that should be happened in the line in between AC to reduce the total phase angle. So this should be the difference along the line, which will be happens about 8.5 degrees to 4.26 degrees. So this is the combination of the mesh and thyristor control of the phase angle regulatory. That should may reduce the cost, and that same result should be achieved by injecting a variable voltage that should be in series of one of the lines, and the balancing of the power flow in the lines are carried out by the use of one of the fax controller devices onto the each and every line phase. So here it should be introduced with one of the loading capability limits. So for the best use of the transmission network and also to improve the loading capability of the whole network, one has to overcome the one of the limitations of the line. That means thermal limitations, dielectric limitations and stability limitations. So thermal limitations means we already discussed when the line is carrying the power over longer distances means it may happens with the one of the I square R loss coefficients, and dielectric coefficients may also influence the line parameters. So this may influence indirectly of the stability coefficients. So that may also treat one of the suitable parameters which must be considered as one of the best use of the transmission parameters to improve the loading capabilities of the system. So this is one has to remove the conditions when we suppose to consider the whole entire transmission network which will be designated as the system. So when you are going to transmitting the power over the long distances means, so what is happening onto the line means one of the I square R losses due to which temperature coefficients influenced. So due to which the loading capability may changes. Loading capability may changes. So all these are the factors we may see when we are going to discuss or enter into the whole network. So this may be treated as one of the transmission line coefficient for the whole network. So this we have to check into the line. So on which line it is carrying the power, it may be 500 megawatts or 200 megawatts or 1000 megawatts. So whatever it may be, the line coefficient that should be carrying the power into the system. So thermal limitations are most important. So as we need to treat the thermal limitations means it will mostly affects as a temperature coefficient that should be interlinked into the dielectric limitations. So that means one parameter is coinciding with another parameter as one of the limitations of the stability. So coming to thermal limitations, this may go with the thermal capability of the overhead lines, which is treated as a function of the ambient temperature case and wind conditions, conductors conditions, and ground clearances are going to be treated. So that means it varies by a factor of 2 to 1. This is due to the variable environment and the loading history. So it needs to be find out the nature of the environment and other loading capabilities. So this has to be that offline computer programs are supposed to be ready for the use to calculate line loading capability based on the available ambient environment and present loading history also consider. What is the present loading and past history? Present loading, past loading conditions. Past loading conditions are going to be treated to calculate the one of the parameters of the power system network. So which are treated in terms of the coefficients of the power system network, which are treated with the programs which are designed to make sure about all the parameters are covering or not. So this should be done making the offline computer programs. So overload line monitoring devices also supposed to be used to know the online loading capability of the line. That means normal loading of the line also decides, but on a loss evaluation basis, which may vary for many reasons. So this has to increase the rating of the transmission line involvement and the considerations of the real-time ratings of the transformer, and which is also to be one of the functions of the ambient temperature quotient, which may be egging of the transmissions and present loading history of the offline and online monitoring systems. So this has to be considered. So based on those parameters, one of the controllers are introducing means the rating of the line may varies. So usually loading capability of the transformer is also used to obtain the real-time loading capability. So for the enhancement of the cooling of the transformer, it also to be considered as one of the factor of increased offload from whatever we discussed. That should be upgrading to the line loading capability, which can be done by changing the conductor of higher current rating, which is required to maintain the structural upgrading of the power system network. So loading capability of the line is achieved means this is to be done by converting a single circuit to double circuit line. So which may also extend up to N transmission line. So if the higher current capability is available means then question arises how to control this high current in the line and also to the acceptable limits of the sudden voltage drop with the high current may be one of the factors that should be treated. So coming to dielectric limitations, this should be considered from the insulation point of view. Many transmission lines, they are supposed to be designed very conservatively. So for a normal voltage operating range, it is rarely possible to increase the normal operations about 10% voltages like 500 kV, minus 550 kV or even more than that. Weekend care must it be taken such that dynamic and transient conditions of the voltage are within the limit range. So modern type of gapless arresters or line insulators are installed with internal gapless arresters or powerful thyristor controlled over voltage suppressors are introduced at the substations. They are used to increase the line and substation voltage. So this must be treated to make sure about the whole system. So coming to the FACTS technology that should be utilized to ensure acceptable over voltage and power conditions. So here the limitations of the stability are there. There are a number of stability issues that should limit the transmission capability. They are transient stability, dynamic stability. Like that, we will introduce various stability factors to make sure about the limitations of these conditions. Steady state stability also to be involved. Frequency collapse we can see, voltage collapse, subsynchronous resonance. All these are one of the forms of the natures for affecting the performance of the whole power system network when it is operating under transmission case. So these are some of the references whichever I have taken. So we can make sure that go with some more videos representing fax controllers, each and every block with compensating element to the system. So that should give a better presentation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.